Okay. Alright guys, so we are just going to go through could say the rest of these problems. There's 1, 2, 3 left, so we're just going to go through them and well, yeah, hopefully we can gauge a thing or two from the problems. Okay, so if you look at the fraction, we have 3 over 1 minus x plus 3x squared plus 6x over 3x squared plus 6 times 2 plus x squared over x cubed minus x squared. So before we do anything, what we have to establish is the signs between the fractions. Okay, and then of course priority, guys, according to BODMAS. Okay, according to BODMAS, priority has to be with multiplication, then the addition. It's like if you are given 1 plus 2 times 3 in a certain expression, then we don't say 1 plus 2 is 3 and then say 3 times 3 is 9. No, we first prioritize multiplication, because in BODMAS, multiplication comes before addition and subtraction. So that's very important. Okay, let's never, guys, forget BODMAS, because when you were in earlier grades, the whole purpose of learning BODMAS is that BODMAS is applied whenever you see a certain expression or a sentence of terms where it is clear that you have addition and multiplication, or you have different operations, right? So we always think of BODMAS, we look at brackets. Of meaning order means roots and exponents, division, multiplication, addition and subtraction. So with this here, we are going to write down 3 over, now the 1 minus x. Okay, for now we are going to leave it, okay, because we are not really going to be doing anything with this particular fraction for now. Plus, now if we look at this and that, our priority is to be looking at this fraction and that fraction. So when we look at these two fractions, we are looking at them as though we are considering these fractions for multiplication, right? So 3 over 1 minus x is just gonna chill there for now, and then we are going to come here, and when we are multiplying two fractions, the method steps that we follow when multiplying two fractions is 1, we factorize the numerator and denominator if possible. That's when we are multiplying. If we are multiplying or dividing fractions, so in the case where multiplication is happening, we look at the numerator and the denominator of each respective fraction that we are multiplying, and we factorize what is we are able to factorize. So let's look at this, 3x squared plus 6x. So for this numerator expression, we can factorize 3x squared plus 6x. Okay, it's going to be 3x, and outside we are going to have x plus 2. Okay, the denominator here, 3 is the highest common factor. We are going to be left with x squared plus 2 multiply. Now here we have 2 plus x squared, but if we write the degree of the highest variable first and then the constant term second, x squared is positive, the 2 is positive, so we can put that in brackets as well. Then when we go to the denominator, we have x squared as the highest common factor, and then inside the bracket we have x minus 1. Close the bracket. Okay, so as I said, guys, what we are looking at here is the addition and multiplication of fractions. So because we have addition and multiplication, what I said is that we first focus our attention on the 2 last fractions because they are being multiplied. Because according to BODMAS, we start with multiplication before we do addition and subtraction. So 3 over 1 minus 1 minus x is going to just chill here for now. And let me take care of these last 2 fractions. How? Remember, the rule is, or the method is, when I am multiplying and dividing 2 fractions, what I do is I look at the numerator and the denominator and I factorize where possible, applying an appropriate factorization. So in this expression in the numerator, I can see that there's a highest common factor of 3x. Then inside I'm left with x plus 2. In this denominator, there's a highest common factor of 3. Then I'm left with x squared plus 2, close brackets. In this numerator, we have 2 plus x squared. So I just reorder the terms. I place x squared first, which is positive, place 2 last, which is positive, and I open a bracket. Basically, I enclose these 2 in the bracket to show that there's a highest common factor of 1 that I've taken out. Then in the denominator, the highest common factor between x cubed and x squared is x squared. Then I put x minus 1 inside that bracket. What is the next step? The next step is you cancel top and bottom. Cancel top and bottom once. Okay, so I can see that x squared plus 2. So let's first start with the numerical coefficient. 3 and 3 will cancel. This 3 and this 3 will cancel. Okay, because 3 divided by 3, in the place of 3 and 3, we are left with 1. Okay, this x that's outside the bracket will cancel with one of these x's in the denominator. So if I cancel, what I'm going to be left with in the denominator is a single x. Whilst here with the x there, I'm left with not x, but I'm left with 1. Okay, just the number 1. So here I'm left with a single x because this x and this x cancels. Here when I cancel it, I'm left with 1. Here when I cancel it, I'm left with a x. All right. Then this x squared plus 2 bottom will cancel with this x squared plus 2 at the top. Then I'm going to be left with 1 and 1. Okay. No, Kanya. How can you get the same answer? What kind of question is that? BODMAS. What does BODMAS say? BODMAS says when you are having different operations, you can't start with addition when there's multiplication. BODMAS says you start with brackets if there are any, then you follow it up with exponents, you follow it up with division. Multiplication, addition only comes later than subtraction. So for instance, 1 plus 2 times 3, you focus first on the multiplication. So the 1 chills there, plus what's 2 times 3? That is 6. What's 1 plus 6? 7. You can't say 1 plus 2 is 3 and then say 3 times 3 is 9. That's incorrect because that's not following the order of BODMAS. Okay, so guys, honestly, okay, I am going to say this. If you are doing pure maths and you guys are failing to see basic things like BODMAS in a given expression, you guys don't think of things like that, then let me just say to you that if you fail to continue to not see basic things like BODMAS, you continue to do so now and forever, what's going to happen is that your mathematics in grade 10 is going to be sadly affected by your lack of attention and by a lack of seriousness and not taking these basics that you learned in earlier grades seriously. And it's going to be affected because when you are doing maths, you don't think more than just what you are looking at. You don't think about some of the other things, or some of the other things that you've learned earlier on are not coming to affect some of the things that you do now. All right, so you need to think of other things holistically when you do mathematics. All right, because you learned these basics like BODMAS earlier on because you are going to be exposed to expressions or sums that have different operations, or let me say different problems that have different operations. And BODMAS is a very crucial concept to be applied in situations such as that. So starting with the addition whilst not taking care of the multiplication first is a big failure on your part, and it will lead to basically not being able to successfully get the answer. Okay, so please guys, let's follow the rules and let's be cognizant or mindful of the rules, because if we are not, then I'm telling you, you guys are gonna say maths is difficult, yet it's not, but it's just lack of attention. Okay, so 3 over 1 minus x plus, as I said guys, this 3 and this 3 cancel each other because cancellation is allowed if it's not across, as long as it is not across an addition and a subtraction sign. So this 3 and this 3 can cancel. You are left with 1 and 1. 3 divided by 3 is 1. This x and this x squared, as I said, cancel, but when you cancel this x, we are left with the number 1. When you cancel this x, you had 2 x's, you had 2 of the x's, so when you cancel 1, you are left with 1x. Okay, there's an x that is left here in the denominator. This x squared plus 2 can cancel that x squared plus 2. This one is at the top, this one is at the bottom. We cancel once. And then what is left now at the top for this entire multiplication of the fraction? 1 times 1 times x plus 2 times 1 gives you a numerator of x plus 2 for the multiplication of what's left over in the numerator. 1 times 1 is 1 times x plus 2 is x plus 2 times 1 gives you x plus 2 alone in the numerator. Let's go to the denominator now. 1 times 1 times x into x minus 1. That's going to give me x into x minus 1. This is the fraction that I get from the multiplication of this with that. Okay, guys, this is very, very important, and I hope you guys are following along. All right, so let's just go back again. We were initially given 3 over 1 minus x, that's a fraction, plus 3x squared plus 6x, that's in a numerator, 3 over 3x squared plus 6 times 2 plus x squared over x to the power 3 minus x squared. So when we looked at the entire sum and multiplication of fractions, we first saw that there's addition and multiplication, which means then in your head you need to think of BODMAS. What does BODMAS say? BODMAS exposes us to the order in which we need to do, the strict order we need to follow when we have different operations. So 3 over 1 minus x cannot be added to this yet. We need to say 3 over 1 minus x plus, then take care of the multiplication of these two fractions. How? Well, when you are multiplying fractions, what is the rule? You must factorize the numerator and the denominator of the two fractions that you are multiplying. Look at the numerator, factorize it. We can see there's the highest common factor here. After seeing that there are two terms, there's a highest common factor of 3x, so we take it out. Then we are left with x plus 2 inside the bracket. Multiplying the denominator, we have a highest common factor of 3. We are left with x squared plus 2. Looking at this numerator, we can order the terms x squared first plus 2, and then in brackets we write that to show that there's a highest common factor of 1 that we have taken out. In the denominator here, we have a highest common factor of x to the power 2. The common base with the lowest exponents is x squared. We take it out, then we are left with x minus 1 in brackets. So after factorizing, the next thing is to cancel the top and the bottom of common things. But we do so once for common things. So 3 and 3 cancelled. We're left with 1 and 1. X and x squared. One of the x's cancelled here. One of the other x's cancelled, but we're left with another x. Okay, so we show that that x is left over, but there's a 1 left over where the x was at the top. Okay, x squared plus 2, this bracket cancels with x squared plus 2, this bracket. We are left with 1 and 1. And that's it. So at the top, we say 1 times x plus 2 times 1 gives you x plus 2 in the numerator. 1 times 1 times x minus 1 is x into x minus 1. That is the denominator. Remember, we had 3 over 1 minus x plus. Now the addition can be taken care of because the multiplication gives us this. Now let's move on. When now we have two fractions and we are adding, what is the method or the procedure that we follow when we are adding fractions? Well, first step is, when you are adding fractions, you first factorize the denominator if possible. In your factorization, please consider dots, difference of two squares, highest common factor, sign chain rule, which applies when there's a minus sign between two terms and you want to change the order, difference of cubes, sum of two cubes, grouping, advanced trinomial, and many others. Okay, so let's come here. Look at this denominator. Is there a factorization that we need to apply? Yes, most definitely. 3 over, take out a negative, write x minus 1. That is the sign change rule applied to this denominator. So that's a type of factorization. Plus x plus 2 over x into x minus 1. Now, very deliberately, I did not multiply the x into the x minus 1 because it's okay when the denominator remains factored. Okay, then step 2, find the LCD. Okay, but before we do that, we just need to make sure that the denominator does not have any negative sign. So 3 divided by something that is negative will give us negative 3 over x minus 1 plus x plus 2 over x into x minus 1. Now if I look at this negative into 3 and then this plus into x plus 2, guys, if there in the numerator I have 2 or more terms, let us be in the attitude of putting the 2 terms in brackets so that we know that this is in brackets. Okay, if there are 2 more terms, do put your numerator terms in brackets. Now let's find the LCD. Okay, LCD, we find it according to the product of the number letter bracket. So if we look at number, we are looking at what's before the bracket, the number that is before the bracket, and the number that is before the letter before the bracket. So we have 1 and 1. The lowest common multiple between 1 and 1 is 1. Then we move on to letter. Here outside the bracket we have no letter. Here outside this bracket we have x. So the lowest common multiple letter is always the common letter or the leftover letter with the highest exponent. Now there's only one x before the bracket. There's no other letter before this bracket. So therefore we have to then say times the x variable, which is x. Okay, times the x variable, because it is the lowest common multiple letter or variable that exists. All right, which letter is the only one that possesses the highest exponent as a letter. We don't have any other letters. Okay, then common bracket, B stands for bracket. Okay, the lowest common bracket is the bracket which has the highest exponent. Okay, if it is unique, this is x minus 1, it's common with x minus 1. All right, so that means we are going to write x minus 1 as a common, lowest common bracket. So all in all, 1 times x minus 1 means the lowest common denominator is x into x minus 1. This is our LCD, the product of the lowest common multiple number, lowest common multiple letter, and lowest common multiple bracket, x into x minus 1. Now, step number 3. After finding the LCD, we form equivalent fractions. We form equivalent fractions of the terms that we have, the fractions, using the LCD, and we put the 2 or more terms in the numerator in brackets. So let's now form equivalent fractions. So if you look at this denominator, it is x minus 1. But if you look at the LCD, it is not just x minus 1, but it is x into x minus 1. We need to make this LCD be the same as this denominator. Okay, this denominator needs to be the same as the LCD. This denominator needs to be the same as the LCD. So in x minus 1, we already have x minus 1. What is missing here in order for it to be like the LCD? What is missing in this denominator? Okay, I'm sure you can see what's missing is the multiplication with x, because the minute we have x, then there it is. This denominator is now like the LCD. But if we are going to multiply by x in the denominator, then it means in the numerator we have to also multiply by x. Now this is an equivalent fraction, okay, where the LCD is being used to form an equivalent fraction with the same denominator. We are short with x, we multiply by x, so what we do in the denominator, we do also in the numerator, we multiply by x. Plus, brackets, we have x plus 2 over, look at the denominator, it's x into x minus 1. X into x minus 1. Is there anything missing according to this LCD? Is there anything missing for this denominator? No. So that simply means we multiply by 1 and we multiply by 1 at the top. So now what we are going to have is a LCD denominator, which we can see present for both these fractions. X into x minus 1 is here, and x into x minus 1 is also here. So that is our lowest common denominator for both fractions. All we are left with to do now is to multiply the numerator. What's negative 3 times x? So for the first term, we have negative 3x. Then positive times x and positive times 2. Positive times x is positive x. Positive times 2 is positive 2. Okay. Then, now what do? We add and subtract the like terms whilst keeping that LCD, because we formed the same LCD. What does the law of fractions say? When we are adding fractions, when the denominators are the same, we keep the denominator, we add the numerators. Okay, so negative 3x plus 2x plus x, gives us negative 2x plus 2 over x into x minus 1. Right? Okay. So what you see now, we form the equivalent fractions of the terms using the LCD and put the 2 or more terms in the numerator in brackets. We then multiply out, add and subtract like terms in the numerator, we keep the denominator. That's step number 4. That's what we've just done. Then step 5, we factorize the numerator if cancellation will result. If further simplification and cancellation will result, we factorize the numerator. So let's look at the numerator. What do we see here? In the numerator, we have, can we factorize the numerator? Yes. What is the factorization? -2 is the highest common factor. What are we left with inside the bracket? X minus 1. That is all over x into x minus 1. Any cancellation that is possible here? I'm sure you can see negative times 2 times x gives me -2x. -2 times -1 gives me back the +2. So now what I have left is I can cancel this and that. Why? Because I can cancel as long as it is not across an addition or a subtraction sign. This is a common bracket multiplied to x. This is a common bracket multiplied by -2. So cancellation can happen. When I cancel, I'm left with 1 and 1. So in the numerator, you say -2 times 1 is -2. X times +1 is x. And this, guys, is your final answer. -2 over x. That is how you simplify this algebraic fraction, which had addition and multiplication, step by step, until we get to the finality of the answer. Okay. Yeah, guys, this is fractions for you. Fractions, algebraic fractions, not difficult at all. Nice, sweet, and savory when you take it one step at a time. Okay. So that is the answer for that one. Let's move on. We have 2 more to go. So let's really look at this one. This is 7 over 9x squared minus 4. The line means divide. Then we have 2 over 2x minus 3 over 3x minus 2. So I want us to first rewrite this. This can be rewritten as 7 over 9x squared minus 4 divided. We use brackets and we say 2 over 2x plus 1 minus 3 over 3x minus 2. Right? So this, the line means divide, but everything underneath the denominator we are going to place in brackets. Very important that here the denominator, which is a subtraction of fractions, has to be put in brackets. Okay. The division comes from the line. This is a divide line. Division is the meaning. Okay. But then you must put these. What you see here in the denominator is obviously the subtraction of 2 things together, so they must be in brackets so as to not lose the essence of what we mean by the division line. So if we are here, then it serves to reason. All we need to look at now is look at this. The relationship is divide with that entire thing, but according to BODMAS, we say we start with brackets, right? Then orders and exponents, division only comes later. So division needs to hold horses for now. We are going to say 7 over 9x squared minus 4 divided by, for now, and then inside this bracket we must go ahead and simplify. So what is the steps for addition and subtraction of fractions? Step number 1, factorize the denominator if possible. apply the sign change rule and all of those things. So here factorization will simply be us writing these two in brackets to show that a highest common factor of 1 has been taken out. Step number 2, we write down the LCD according to our number times the lowest common factor letter times the bracket. Okay, bracket which has the highest exponent. Every unique bracket with the highest exponent is to be written once, but if that bracket is common, even if it is for 2 or 3 brackets or 1 bracket, we look at that common bracket and we regard it as unique and we include it in the multiplication of the bracket. So let's look at highest common factor number. When we look at number, we are looking outside the bracket, not inside. So there's an invisible 1 here, there's an invisible 1, which means the lowest common multiple number is 1. Letter, we look for a letter outside the bracket, we look for another letter outside the bracket, we can see none, so there's no letter. Bracket, like I said, the common bracket with the highest exponent. Also, if it is unique, 2x plus 1 is unique, it is the only one with the highest exponent. 3x minus 2, it is unique, it is the only one with the highest exponent. So the product of 2x plus 1 and 3x minus 2, that's what forms what I call my lowest common denominator, the product of those two. So what are we going to do now? We are going to say, well, in order for this 2x plus 1 to be like the denominator, what is it missing? A multiplication of 2x plus 1 with 3x minus 2. Isn't that the case on this side? But remember, if we multiplying here by 3x minus 2, which is missing, it means at the top we multiply by the same thing, 3x minus 2, which is missing. Which means, in other words, this here is the equivalent fraction of 2 over 3x, 2x plus 1, where the LCD is the lowest common denominator. So that's why we multiply. What was missing here? 3x minus 2. So what we do at the bottom, we do at the top. So 2 is also going to be multiplied by what was missing, which is 3x minus 2. Minus 3. Now, who is missing here? 3x minus 2 is always there. Who's missing? It's 2x plus 1. This is the same lowest common denominator. Then if it was 2x plus 1 that was missing in the denominator, it means 2x plus 1 is missing where? In the numerator. Now we can multiply out, add and subtract like terms. After forming equivalent fractions of the terms using the LCD and putting 2 or more brackets in numerators that have 2 or more terms in brackets, we now can multiply out, add and subtract like terms in numerator and keep the LCD. So let's go. 2 times 3x, that's 6x. 2 times negative 2, negative 4. Negative 3 into 2, negative 3 into 1. Negative 3 times 2, negative times a positive, negative 3 times 2 is 6, the x next door. Negative times a positive, negative 3 times 1, 3. That's going to be all over the same LCD. Remember, the LCD was designed to make the 2 denominators that are not the same to basically become a lowest common denominator that can be shared for both fractions and which we can form equivalent fractions with. Okay, now what is left? Remember, we are still keeping this for now because we have not dealt with division yet. We now add the like terms. 6x minus 6x is 0. Negative 4 minus 3 is negative 7 over 2x plus 1 into 3x minus 2. Now, if we look at what we have now for this fraction, we can't simplify any further, so we leave it like this. Okay, we leave the denominator like this with the brackets open. Okay, yeah. With simplification, we leave the brackets as they are. We don't multiply them out in the denominator. Then let's write 9 over Now, we are now going to deal with division of two what? Fractions. Okay, we are going to deal with division of two fractions. So now, what is the rule when we are dividing two fractions? If we have divide in the mix, then we must apply KCF. What's KCF? K means we keep the first fraction. C means we change divide to multiply. And then F means we flip the second fraction after the division that we've changed to multiply. So we apply KCF whenever we have divide. Okay, keep 9x squared minus 4, change divide to multiply, flip the second fraction. So what you see is the application of KCF divided by -7. See? Hopefully it makes sense. Right? Then after applying KCF, now that we have multiply, remember that the method when you are multiplying two fractions is that we must factorize the numerator and the denominator of everything. 7 is just 7. We can't do anything with that. 9x squared minus 4. What type of factorization must we apply with 9x squared minus 4? How many terms do we have in the expression? In the denominator, 2. Should we apply the sign change rule? No. Is there a highest common factor? Yes, it's 1. But 9x squared minus 4 in brackets gives us a unique type of factorization, which we call what? Yes, Emmanuel. It's the difference of two perfect squares. 9 is a perfect square. X squared is a perfect square because it is a variable raised to an even number. 4 is a perfect square number. So what we are going to do is we are going to open two brackets, put plus and minus immediately because a negative constant suggests that we are going to have different signs. Square root of 3 of 9 is 3. Square root of x squared is x. So we have 3x here. But then the same 3x needs to be written for this first term in the other bracket. Very good. Who's this? Mr. Diamond Ruben. That is the factorization indeed. Then the square root of 4 is 2. So we have plus 2 minus 2. So 3x plus 2 into 3x minus 2 times 2x plus 1 into 3x minus 2 over -7. Factorization, factored, then this is just 7 and -7. Next step, we cancel top and bottom if there's anything common. So with your pencil, guys, 3x minus 2 can cancel out with 3x minus 2. We are left with 1 and 1. 7 and 7. 7 divided by 7. We are left with 1 and 1. Okay, this one is negative. So now there's nothing else to cancel because they have 3x plus 2 in the numerator, in the denominator. We have 2x plus 1 in the numerator. Nothing else to cancel. So we are going to multiply numerator and numerator, denominator and denominator with what's left over. So 1 times 2x plus 1, that gives us 2x plus 1. 3x plus 2 times -1. That's negative 3x plus 2. Then we take the negative sign. Positive divided by negative will give us a negative into 2x plus 1 over 3x plus 2. Okay. Emmanuel, where are we getting the negative? The 7 was negative. The 7 was negative. It was always negative, the 7. Okay. So that's where we got the -7 from, because when we added 6x minus 6x gave us 0. Then the minus 4 minus 3 gave us negative 7. So this negative 7, when we change divide to multiply, the negative 7 went to the denominator. It was there. All right. So that negative sign was there. Don't leave it behind. Okay, then we canceled the 7 and 7, but then the negative sign was left, negative 1. So that's why 3x plus 2 times 1 times negative 1 gives you negative into 3x plus 2. Okay, and then the 2x plus 1, 1 times 2x plus 1 is 2x plus 1. But remember, this negative sign, take it back there. Positive divided by negative is a negative. So then at the top there, you can distribute the negative sign, negative 2x minus 1 if you want, into 3x plus 2. Okay, and there it is. Okay, so from what I've said, I think that is saying that we can simplify the numerator, but the denominator we can leave. We don't have to multiply out if there's anything that needs being multiplied out in the denominator. The denominator just can be left with brackets opened without them being multiplied out. So there we have it. That is the simplification of all of this. All right. Now I want to do the very last question, guys, in this document of mine, and then I'm gonna call it quits. Grade 10s. Yeah. Okay. This has been a meal. You guys need to go and subscribe to my YouTube channel. The link is in my bio. All right, some of you are asking me about, can you do factorization on this, do factorization on that. Yesterday, for instance, I did a whole entire lesson on factorization where I was doing various and different types of exam questions. I've uploaded that video. It's on my YouTube channel. You can go and look at a video that I uploaded recently, which is the live lesson that I did here on TikTok. I uploaded it raw as it is, so it has music, some of it is just silent. Go and check it out. There I did factorization. I explained factorization. Guys, let me just show you. This was what was happening. This was yesterday's stuff. Look. You know, we started here. I explained what factorization was from the beginning and the method that we can use, you know, how many terms, applying the sign change rule, taking out the highest common factor according to the sign, the number, and the letter, taking out the highest common factor according to the sign, number, letter, and bracket if necessary, leaving what is left over inside the bracket, checking if inside the bracket there's anything to be factorized, and considering that it may be difference of two squares, quadratic trinomial, cubic factorization, whether it be sum or difference of two cubes, grouping factorization, or advanced trinomial or trinomial factorization. Okay, then I did these problems one by one, you know, step by step, beautiful explanation, one by one. Did these yesterday. Different types of factorization. Okay, consolidated factorization. So on my YouTube channel, guys, I have uploaded the video for this, what I did here. All of this, all of it, the explanation, long video, I think 2 hours and something minutes. Okay, advanced trinomial, like I did all the types of factorization. And then I also did a question which was pretty interesting. If x minus 1 over x is equal to 7, determine the value of x squared plus 1 over x squared. So I looked at that. There was a grade 8 learner that came through that asked about the subtraction of expressions. So I helped that particular learner out. And then there was a grade 9, another grade 8 learner that came through that was asking about ratios and dividing quantities in a specific ratio, because in grade 8 and 9 they are doing such. So I answered those questions. Also rate as well, questions grade 8 and 9. So long video, go and check it out. It's uploaded there on my YouTube channel. Check it out so that you guys can also catch up on some of the other things that I've done. Then you can, if you still have questions, you can ask. Okay, follow the live creator. Go to my YouTube channel, gift me, guys. I surely you guys are getting value for what you are seeing here. So if you can gift, if you're in the position, please guys support my live goal there. 20 finger hearts, only one has been given. Really and truly, it would be nice if I could get more. Anyways, let's continue. Let's finish off this. x over 1 minus 4x squared divided by brackets 3x over 4x squared minus 9 minus 2 over 4x squared, close the bracket. So that is the last question that I'm going to do for the night. Okay, so what do we do here? We have division, we have brackets, and inside this bracket we have minus. So what is our priority? Okay, according to BODMAS says what? Okay, if we have division, we have brackets, we have subtraction, what is our first priority? Okay, according to BODMAS, we need to take care of what? Brackets. Thank you very much. So we are going to say x over 1 minus 4x squared. Keep this for now. Keep divide for now. Let's sort out what is in the brackets for now. Liam, wait, you need to calm down. BODMAS, brother. BODMAS. Inverting and multiplying. No inverting and multiplying for now until we take care of, according to BODMAS, the bracket. So now we are going to focus on the subtraction that is inside the bracket. So what is 4x squared minus 9 and 4x squared? What we are going to do, we are going to factorize the denominator. So let's start with that. 3x over 4x squared minus 9. That is going to give us 2 brackets. 2x plus 3, 2x minus 3 minus 2 over 4x squared. Okay. Then we want the lowest common denominator. Remember I said number times the letter times the bracket. So let's see in these two fractions, lowest common denominator. So number, we look outside this bracket, we look, there's 1. The number before the x squared is 4. So 1 and 4, what's the lowest common multiple between 1 and 4? It is 4. Move on to letter. Before these two brackets, there's no letter, but this denominator has the letter x squared. Okay, when we talk about letter or variable, we are not looking at the variable inside the bracket. No. We are looking at the letter outside the bracket, if there is one in the denominator. There isn't one here in this denominator, but there's one here. So we go for the variable with the highest exponent. X squared is unique, so it means we are going to include it in the product of the number and the letter. Then bracket. We have 2x plus 3, we have 2x minus 3. They are the only ones that are like this in the denominator. We don't have any other. So the brackets, as they are 2x plus 3 into 2x minus 3. This, guys, is our LCD. 4x squared into 2x plus 3 into 2x minus 3. No one is going to... You are entitled to your opinion. Thank you so much for sharing your opinion. BHSD1 nerd. Thank you for sharing your opinion. Maths is useless, and that's very much welcome. Calculators exist for a reason. Thank you so much for your opinion. Okay, calculators do indeed exist for a reason. I hope you enjoyed commenting in this live lesson. Okay, so our LCD is 4x squared into 2x plus 3 into 2x minus 3. That is the LCD. Okay, then we are going to make sure that both of these denominators have this LCD formed. So if we look at the LCD and we compare it with this denominator for this fraction, what do we have? We have the 2 brackets. What are we missing? We are missing the 4x squared. So we need to just multiply this denominator with 4x squared. Okay, 4x squared is missing. So what I'm going to do is I'm just going to write one common LCD, because I know most that I'm going to multiply the denominator by what is missing. So what's missing here is 4x squared, which means I'm going to multiply 3x with 4x squared, the missing thing as well. All right, let's move on to negative 2. If we look at the denominator, what is missing compared to the LCD? The 4x squared is there. So what's missing is the 2x plus 3 into 2x minus 3. So we are going to multiply by that in the denominator so that we have the LCD formed even for this fraction. But what we do at the bottom, we do at the top. So that means negative 2 is going to be multiplied by 2x plus 3 into 2x minus 3. Okay, yeah, this is in the bracket. Let's continue. We are not done. Let's keep this for now until further notice. So let's continue now, and we multiply out, add and subtract like terms for the numerator. So 3x times 4x squared, that gives you 12x cubed. Then we'll multiply out this. Negative 2 can chill for now. Let us multiply these two brackets and fold them. This with that, this with that, this with that, this with that. I'm sure, guys, if you multiply this out, you know that you are going to go back to 4x squared minus 9. Okay, because that is the reverse of difference of two squares. This is the reverse of difference of two squares. So 2x plus 3 into another 2x minus 3 will give you 4x squared minus 9. Okay, I hope you understand. Then the negative 2, right, we are going to distribute that now. Okay, remember the LCD is kept having open brackets as it is. Now we are going to distribute this negative 2 inside this bracket. Okay, let's not forget my x over 1 minus 4x squared divided by. So we are going to say 12x cubed minus 2 times 4x, negative 8x squared, minus 2 times negative 9 plus 18 over 4x squared into 2x minus 3 into 2x plus 3. Let's not forget the x over 1 minus 4x squared divided. We're still maintaining that. So now let's look at this and check. Do we have any highest common factor for the numerator? Do we have any highest common factor for the numerator? Liam Paidia says we do. Okay. Alex Paidia says we do. So between 12, 8 and 18. 12, 8 and 18. 12, 8 and 18. No, 4, guys, is not the highest common factor. 4 doesn't go into 18. Right? So we need to think of another highest common factor. Okay, not 4. 4 is not the highest common factor. Okay, so we're going to say 2 has to be the highest common factor. This leaves us with 6x cubed. 2 times 6 gives us back the 12. 2 times what gives us 8? 2 times 4, 4x squared. 2 times what gives you 18 plus 9. That's all over 4x squared into 2x minus 3 into 2x plus 3. Now notice something here. The 2 and the 4 can cancel. What does that leave you? 2 goes into 2 once, 2 goes into 4 twice. Okay. Yeah. Let's not forget x. Okay. Now we are left with x over 1 minus 4x squared divided by 6x cubed minus 4x squared plus 9 over 2x squared into 2x minus 3 into 2x plus 3. Then what happens now is we can look at this fraction, there's one term, and then this fraction, there's also one term. Okay, we have simplified sufficiently for the numerator and the denominator. We can't simplify any further. Now we can come and check on divide this fraction divided by that. So we are going to apply KCF. What does KCF mean? We keep the first fraction, we change the division sign, we flip the second fraction. So when we flip it, this is what we have at the top. The bottom becomes the top, and the top becomes the bottom. Okay, it would be nice to factorize this, but unfortunately I can't. So it has to be left like that. So written properly, we can factorize this denominator. We factorize it, of course, with the intention that it's going to do something, but sometimes if it doesn't, it doesn't. So we apply the sign change rule firstly. Okay, take out the negative sign so that it can allow me to change the sign and change the order. Then we can factorize that x over the negative times the positive, negative at the top. I can factorize using difference of 2 squared, 2x and 2x. The square root of 4 and the square root of x squared is 2x. Plus minus square root of 1 is 1 and 1. Okay, yeah, and then basically, guys, honestly speaking, you can see there's nothing that can cancel. That 2x plus 1, nothing at the top. That 2x minus 1, nothing at the top. This x, nothing at the bottom. This x squared, nothing at the bottom. This 2, nothing at the bottom. This 2x minus 3, nothing at the bottom. This 2x plus 3, nothing at the bottom. So all in all, when it comes down to it, you're going to multiply this with that. So the negative x at least times the 2x squared will give me negative 2x cubed into 2x minus 3 into 2x plus 3. The denominator is going to give me 2x plus 1 into 2x minus 1 into 6x cubed minus 4x squared plus 9. The least that you can do, you can leave the denominator as it is. You can multiply out the numerator. So negative 2x cubed. This will give me 4x squared minus 9 over 2x plus 1 into 2x minus 1 into 6x cubed minus 4x squared plus 9. Then finally, in that numerator, I will say negative 8x to the power 5 plus 18x to the power 3 over that entire denominator, factorized as it is, without really making sure that we distribute, and you leave it like that. There's nothing wrong here. Nothing wrong at all. There's nothing wrong at all. The question in and of itself is the way that it is, so that those who are fluent in mathematics can ensure that they are doing steps correctly. Absolutely nothing wrong here. The only reason you are saying there's nothing wrong is because you are used to doing questions where it tends to simplify out simply. This question is designed by its nature to be complicated, so that those who are astute and who pay attention and who are focused as they go through the question, the steps, step by step, they will see that, oh, okay, you get to a fundamental place, for instance here, where you factorize the numerator, you factorized the denominator, you factorized everything, but you can see there's nothing that cancels out. When there's nothing that cancels out, guys, well, all that is left to do is to multiply the numerator, all right, and then to just keep the factors of your brackets in the denominator as they are, because there's nothing more that you can do. It was written correctly in Bisemnyam. it was written correctly. Unfortunately, if you were not here from the beginning, then I guess you are going to say it was written incorrectly. The question was written correctly, everything was written properly. Yeah, so this is complex, all right, because we anticipate cancellation for everything, but there are cases and there can be questions where cancellation is not feasible and possible after factorization. Okay, all right. So yeah, guys, that was that. I'm glad that we could reach. This is obviously the end. Okay. No, it wasn't written incorrectly. It was written correctly from the book. Okay, this was a question that was written exactly as you see it. So unfortunately, if you are going to be arguing and saying, no, it was written incorrectly, then unfortunately, you're the kind of person that will never anticipate higher order level questions. And since you are a person who does not anticipate such, when it is asked, you are going to say, no, that question couldn't have been like that. This question was like that. Okay, I wrote it out myself. It was like this exactly. Okay, no error in writing out the question. So unfortunately, if you are still arguing about it, then I guess, yeah, that's you. Okay, guys, thank you so much. This was that. So yeah, I unfortunately cannot extend the live any longer. I have been here for quite some time doing this, but yeah, we'll see you again, maybe tomorrow sometime, in our next installment of maths problems for a specific grade, whatever it is. But thank you for joining in. It was great.